Welcome back to another video, everyone, and in this one we're going to be taking a look at the area of sectors. It's going to be a little similar to something that we covered in a previous video about the arc length, and we're going to use a very similar approach to solve for the area of a sector. All right, so let's go ahead and dive right in. So it's first important to define what is a sector. And so a sector is simply just the portion of a circle that lies in between two radii and the subtended arc. That's kind of a complicated way of saying you're basically cutting out a slice of pizza, all right? So you can imagine that you basically have the middle where your radii will start from, of course, at the origin, and then wherever those two ends end on the circle, as long as you have that arc that's kind of cut out by them, there's going to be a certain portion of the circle that you are taking into consideration when it comes to the area. It's a certain fraction of the circle, all right? And that's exactly what it is that you're doing. So if you think about this, a full circle is a 360-degree rotation. Now, I want you to imagine that we have some kind of angle theta here. So what exactly would this look like? So I want you to think about the area of a circle being pi r squared. Now, that's when we're doing the entire circle, which again, you can think about these two radii being 360 degrees all the way around, coming back to the same point. So you're taking in the entire circle into consideration. Now, if you're doing the area of a sector, what you got to think about is, hey, what fraction of this, of the entire circle am I taking into consideration? So if I think of theta out of 360, I can then say that my area of the sector is going to be, this angle out of 360 times pi r squared. And the reason why that works is because theta is simply just going to be the angle of the rotation between where I'm starting with my radius, my first radius, and then where the second one is going to end. So if I take that angle out of 360, I'm going to get the correct portion of the circle that it is, the correct ratio or the correct fraction that it is. So if I think about that, as long as I take into consideration here and apply it to pi r squared, well, I'll get the area of the entire circle multiplied by the fraction or the section that I am wanting to find the area of, and that'll give you the correct area. But let's take a look at an example to really make sure that this is clear and easy to follow. So in this example, a crop sprinkler is going to be in a circular shape, and it's going to have a radius of 5 from the middle. Okay, so it's kind of just spurting out water all over the place going in a circle. Now, what we want to do is we want to find the area of the sector BAC, okay, because this sprinkler is actually only going to be able to water between 120 degrees of rotation. So we want to figure out what kind of plot of land, what area of grass is this actually going to be watering. So we know that the central angle is 120 degrees. We know that the radii are 5 meters each. And we are given the formula that I already previously gave that, hey, we're going to take the area of the circle pi r squared and then multiply it by the fraction of the entire circle that we are considering. So this is actually quite simple because the area of this sector is going to be this 120 degree angle all over 360. That's the portion of the circle that I am considering. Multiply by pi, then r squared would be 5 squared. And as long as I put this into the calculator correctly, I'm going to get the correct answer. And in this class, we're going to be doing 3 significant figures as a standard way of rounding or representing our answer. And so what you would find is that your answer is going to be 26.2 square meters. So I have 3 significant figures. But sometimes we might be given the area and we might want to find or solve for the central angle or the radius. And how do we do that? Well, let's take a look right here. So I'm given that the area of sector BAC with a radius of 13 is 30 pi. I want to find the central angle. So what helps is if I write out my formula where I know that I am going to have the area of the sector is equal to theta over 360 times pi r squared. And so now I can start plugging in values. So I know that my area is 30 pi. We can call angle theta or x, it doesn't matter. We'll call it 360 times pi, and what is r? That is 13 squared. Now, if you're using a Ti-Nspire, you could go ahead and use nsolve for this if you would like. However, if you are not and you wanted to calculate it a little bit more manually, you would just isolate for x, the same way that we do for any two-step equation. So I have 13 squared pi over here, so I can have 30 pi all over 13 squared pi is equal to x over 360. So I'll multiply 360 times 30 pi all over 13 squared pi. Now, yours might look a lot different, but you might want to cancel out the pi's. You might want to do 13 squared and then keep simplifying down. But again, if I'm at least have a scientific calculator, maybe I don't have the Ti-Nspire to use NSolve, I could put this into the calculator and get the correct answer. So again, if you want to keep simplifying down, you're more than welcome to. But you would end up with an answer that x is going to be 63.9 degrees. That should be your answer to 3 significant figures. Okay, so I hope that helped. I hope you now realize that really the area of a sector is just kind of the same thing as finding the area of a circle, but you're just taking a portion or a fraction of that circle into consideration. And as long as you know what the formula is and your known values, you can either rearrange to find what you're looking for or just put it into the calculator a bit more simply and hit enter. Okay, I'll see you all in the next video.